Okay, so we're in 10-1, and you're just doing 10-1 and 10-2. We slowed down a bit because of the stay-at-home order and didn't get quite as far as we would have it in a normal pre-cal class. But these are two things, or it's actually one thing, just one, and then more complicated things you need to know for calculus. So, and I'm going to put this on the final exam, so make sure you pay attention and know how to do it, okay? So we're talking about something called partial fractions. So you have this rational expression right here. Look at this rational expression. And it can be written as the sum of one of two or more fractions, okay? And these are called this process is called partial fraction decomposition. So this is the same fraction. You know, if we were to multiply this, get common denominators, this is what we would get. So it's like going backwards from getting a common denominator to actually breaking it back apart. So the individual fractions are called partial fractions. Okay, so the next slide tells you the method. So here we go. We have this partial fraction, this rational function, and we want to split it into partial fractions. So the first thing you do is you factor the denominator. And so this thing doesn't work if you can't factor the denominator. So you have to be able to factor the denominator, or, you know, if it doesn't factor, then you can't do it. And there's a difference between you can't and it doesn't. So this does factor. X squared plus 6x plus 8 is the same thing as x plus 2 times x plus 4. And so then you write it as the sum of two fractions. So you're going to write this whole thing as 3x plus 2, the original problem, over x squared plus 6x plus 8 is equal to something over x plus 2. You take the first factor, plus something over x plus 4, because that's how you would get this common denominator. So that's the second step. The third step is multiply by the least common denominator so that you can get eliminate the denominator. So you multiply by the LCD to eliminate the denominator. So we would say that 3x plus 2 is equal to, and then what is this one missing to have a common denominator? X plus 2, and this one is missing x plus 4. So it's a times x plus 4 plus b times x plus 2. Now you can just look at this as cross products, and it's faster to think of it. I just wanted to show you where it comes from. You can do a times x plus 4 and b times x minus 2. And that's equal to the numerator, okay? It wipes out the denominator and wipes this out. Okay, so now you're going to multiply that out. So 3x plus 2 is equal to ax plus 4a plus bx plus 2b. All right, now group the like terms together. So 3x plus 2 is equal to ax plus bx, those are the x terms, plus 4a plus 2b. Those are the constant terms. There's no variable in there. And so then we're going to write a system of equations. Well, wait, we got to group them. So let's write one more time. 3x plus 2 is equal to, now factor out the x, and you get a plus b. And factor out, well, you can't factor anything out of this, so you would just say, you could do it too, but it doesn't help. The constants is 4a plus 2b. Okay, it says write a system of equations. So before you go, let's look at this. This means that this is a plus bx. Doesn't that have to equal 3x, right? and then the constant has to equal that. So we can say that a plus b has to equal 3, right? From this example right here. And 4a plus 2b, the constants have to equal 2. So we can write a plus b equals, a plus b, we're going to solve this system of equations now. And you should remember that from Algebra 2. A plus b equals 3, and then we have 4a plus 2b equals 2. And then you can pick whatever method. I'm going to do elimination. I'm going to multiply this by, let's say, -2. So the whole thing by -2, so that, and then I can add. So that would be -2a minus 2b equals -6. And then I can add those together. -6. And now I'm adding these two equations together, so I get 2a, this goes to plus 0, is equal to -4. So a is equal to -2. And then go back here, if a plus b was 3, then -2 plus b equals 3, so b equals 5. And then you write it out as a partial fraction decomposition. So a was -2 over, what was our a? X plus 2 plus 5 over x plus 4. Okay? So that's how you do proper, when you have a proper denominator. Okay, so let's try some. So the first example,